Ladies and gentlemen, good afternoon. I'd like to take the opportunity to thank Larry for hosting a Fire Chief's View on this important matter, and just introduce you for a second what you may be in for. The best I can tell, we have about 40 minutes worth of slides that covers the gamut of this topic from a fire chief's perspective. I hope I've had the opportunity to meet many of you somewhere in my travels. If not, I would certainly provide a brief introduction. My motive for doing this, if you don't recognize the photograph in front of you at the top, is the National Fallen Firefighters Memorial in Emmitsburg, Maryland. Firefighter safety is of grave concern to myself and the peers around the country who are dealing with these fires, and I hope that in addition to many other things, I'll be able to make my case for that by the end of the day. I am a graduate of the Fire Protection Engineering curriculum at the University of Maryland, and I have had the opportunity to serve a 30-year career in Montgomery County, Maryland, just outside of Washington, D.C., retiring as fire chief there in December of 14. And I've been here in the city of Hagerstown in the fringe of Western Maryland for about a year as the fire chief. So I would like to just qualify that this is not the opinion of either my former employer or my present employer, but rather my own thoughts on this construction and the hazards they pose. The presentation you're about to see really was prepared for an audience of fire chiefs, and it is very much a fire service perspective, absent maybe some of the finer detail that we may have to get to in questions. Nonetheless, I would also like to qualify a few things. There's no greater supporter on planet Earth than Steve Lohr for the use of automatic sprinklers in any occupancy. This presentation is in no way intended to favor or discredit any particular construction materials or methods. And finally, I hope to be an advocate for fire departments everywhere across the nation that are impacted one way or the other by Type 5 R2 construction. My position on this, having lived through this in Montgomery County, is that the codes have simply been relaxed too far in multi-story apartment buildings that are partially protected with 13R sprinklers. And I've titled this The Perfect Storm. If you're not familiar with the fire that occurred in January 15 in Edgewater, New Jersey, I'm just going to give you a perspective without the fire chief's commentary. Now, in this particular fire in 2015, 12 mutual aid fire departments had to respond, including FDNY Marine One for water supply out of the Hudson River, and they were unable really to stop it beyond what you saw in the short video. All of us deal every day with rules, and more rules. Here in Hagerstown, we currently enforce the International Building Code 2015 edition. This really come to prominence after 2009, as I recall, and we could talk about that in some detail. My position is that we are seeing, never seen before, area and height limitations that are just overwhelming for even the best equipped fire departments in the United States. Here's an example of a complex in Potomac, Maryland. If you look at this from the perspective of where would the fire department set up to deploy elevated streams in the unprotected attic areas of these buildings, I think you'll see that we really don't have an opportunity to be successful there, much less access through the center courtyard other than the horseshoe-shaped circle. These buildings are up now. They were not when I left Montgomery County. They were proposed. This is the site of an old quarry. And you can see to the rear and to the sides that access is severely limited. So what are some of the challenges for the fire department, any fire department? Height and area increases, access and building coverage, the types of fuel, which has been well documented in the last several decades, and engineered components in lieu of structural components that have mass. Now, I will be the first to acknowledge that the engineered components make a great deal of sense for architects, engineers, builders, and the cost savings achieved by those. But from a fire department perspective, what you're looking at there is large, open, unventilated spaces in unprotected areas of the building where utilities run, and if fire enters those spaces for any reason, it's off to the races, and the sprinklers are typically not going to touch it. Trade-offs for sprinklers, I support, certainly. We have made great progress in that area over the decades in order to get sprinklers in buildings, but they are not the end-all, be-all. Some of these buildings, many, if not most, have very large unprotected areas that the end result is when a fire occurs there, the building's burned to destruction. These sprinklers, 13R systems, are designed for life safety, not total building protection. I want to talk a little bit about legacy Type 5 construction and what we were used to. So what we're used to is typically 2 stories or 3 to 4 stories with either peaked or flat roofs, combustible or non-combustible exterior walls, enclosed or open stairwells, one-way egress if you're coming down the stairs, and other than that, if I had a nickel for every time I was on a fire where we rescued people off of balconies because they could not get down the stairs, I may not be working today. Some of the things that were present: 1-hour tenant separation, self-closing door hardware, and the problem with these buildings at that time in the 60s and 70s was vertical voids everywhere, plumbing chases everywhere that ended up, regardless of where the fire started, it ended up in the void spaces in the attics. Just more examples. This is what I would describe as a cookie cutter garden apartment, and I listed here for area. 50 by 150 individual buildings, typically 12 to 16 units, and approximately 7,500 square feet per floor. Some of the construction features, but you can see really that even the stairwells made out of steel or concrete, brick veneered stairwell. If they could overcome the smoke, they could typically get out of these places in a reasonable time frame. When we started lumping a bunch of them together, we had to create fire lanes to be able to get apparatus, vehicles, and equipment into place, develop water supply strategies, etc. But our experience really was open doors created issues. If the self-closing hardware did not work, in Montgomery County, Maryland, we actually eliminated the use of fire extinguishers in stairwells. Our experience there was that people, rather than call the fire department, chose to fight the fire until it got away from them, and we had significant delays and alarms. Now, these complexes, as you can see, even in that 50 by 150 model, when they're linked together or in courtyards or back fire lanes, long attack lines and position on those buildings was tough. Then we went to just before 2009, sprinklers come into vogue, residential sprinklers. We extended the traditional 3-story by adding another story and up to 20 feet of unprotected area in the attic space, as long as 13R sprinklers were in place. We had some mins and maxes, and I won't quote the code verbatim, but typically that was 60 feet from the lowest point of fire department access typically a parking lot over parked cars, etc. We had extensive use of floor and roof trusses, extensive increase in the use of combustible siding, and if, for whatever reason, these fires got outside of the protected spaces where sprinklers were, we had our hands full. And the reason for that is all the things we've already discussed. And the fire service, we're a little cynical about this. We say, hey, these places are no better than stapled together. We all know what a gusset plate is. We know what that mass reflects there and how quickly they fail when exposed to fire. So our experience as firefighters is these things will fall on your head and kill you before you can put lines in place, sometimes with little or zero warning. As we continue to make trade-offs for this type of construction, and particularly for automatic sprinklers, developers wanted smaller footprints. So the width of streets were allowed to be narrowed. So here is a representative ladder truck, actually two different ladder trucks, that require 16 feet of width to be able to fly an elevated stream. And I think the next slide reflects it better. Here, we have to strategically place between two parked cars, trees, lampposts, and all the other amenities that come with this kind of development just in order to go to work. And sometimes that's not ideal for the buildings we're trying to protect. This is a significant challenge to fire departments everywhere. So on to our real topic today, post-09 Type 5 construction. We see this in a variety of configurations. Some of these, I'll show you in slides coming up, 4 to 6 stories wrapped around a garage or courtyard. I believe that they were affectionately termed Texas donuts. That's one of the places where this has been an issue. I like to tell fire chiefs this is coming to a town near you. If you don't have it yet, it's coming. As old stuff is replaced, this is what is coming. So we've already talked about these unparalleled height and area limits for R25B. I think the code, the table in the code still says in 2015 that 7,000 square feet plus 100% increase if it's equipped for 13R sprinklers. Draft stopping every 3,000 square feet using either half-inch gypsum or 15/32 plywood. Severely limited fire department access. That is a common theme throughout here. You'll hear it over and over. Developers also want the number of parking spaces per residential unit increased. Therefore, access for the fire department is even more challenged. The street width gets narrower and narrower. In parts of the country where we have snowfall, they want pretty landscaping, all the things that go with it. These all hinder the performance of the fire department. The spacing of buildings is a primary concern. I'll make an argument for that in a minute. But in my education and experience with the fire department, this is what I know. Wood plus wind equals a conflagration. A conflagration is a fire that jumps natural barriers. In this case, streets. It could be a stream. It could be parking lots. It could be whatever. These things typically go building to building, particularly with wind. We've talked about the wood trusses. We've talked about the other lightweight construction components. And then I would simply ask you as we go through these photographs just to consider from the fire department perspective the volume of these unprotected spaces, which are, in my experience, unparalleled. Here's one going up in Montgomery County, actually two, but nevertheless, everybody in this audience knows that buildings are divided into several separate buildings from a code perspective based upon maximum height and area restrictions in the IBC. I go back to my core belief that we have simply extended those height and area restrictions too far. The unprotected attic space, here's one that reaches the limit of 20 feet above the finished ceiling. A lightning strike, a set fire, a utility appliance, anything that starts a fire in that space, we are almost beyond the ability to effectively fight if we don't get there in the first couple minutes. Triple jack stubs that you see on the ground floor of these structures to hold them up eliminates what we used to practice as a wall breach for firefighter self-rescue from one compartment to another. Vertical 2-hour assemblies typically extend to the underside of the roof deck, no surprise. But here's where we get into some of this height area stuff. In this particular building, it serves as a 6th floor from grade, or in the terms of the code, a 5th floor with a loft or a mezzanine. I simply say, please, from the fire department perspective, not the code perspective, from the practical working fire department, 6 still equals 6. It is, for all intents and purposes, we have to treat it like a high-rise. This is an atrium in a building that consumes literally a square block wrapped around a parking garage in downtown Rockville, Maryland, completely lined with combustible siding. That is the preferred exit for people to get out of this building that houses over 300 dwelling units. Beyond a reasonable person, I think. Back to the photograph we've already seen. We'll have some better examples, but the type 1 first floor podium, concrete typically, does not count as a floor or story. That makes good sense for the codes maybe. From the fire department, it is nonsensical. Some of these units, you're looking at units that cost $1.2 to $1.5 million a piece. I'm talking about the individual apartment or condo units in this particular development, and they can be anywhere from 800 to 4,000 square feet per unit. When the fire department fights a fire in a 4,000 square foot single family detached dwelling, it's a challenge. Now we have all these linked together, hoping that the sprinklers will catch the fire early and it does not originate outside of the protected space. You all know that if the loft or mezzanine is less than 1/3 of the area of the finished floor, well, it doesn't count either. So if you look at that photograph and simply count, there's 6-story buildings, no matter what. And depending on what side of them you're on, they may even be more. The Metro Wrap, the Texas Donut, parking garages, we can't get pumpers, ladder trucks, whatever, to the rear of these buildings. By design, we cannot. It is essentially a horizontal high-rise. So for us to access those buildings, deploy horizontally, it takes more resources than we have typically to be able to get that done efficiently. Podium construction, here's a good example. We'll come back to another slide of this in a minute. In this case, the concrete podium is 2 stories at this end. Occupant egress, this building also has a very large courtyard. This is while it was under construction in Silver Spring. It's up and built now. So here's this exterior combustible construction. Here's another buildings that, although separated horizontally by code, this is probably, and it's only the portion that fits in the photograph, this building probably has 800 to 1,000 foot of frontage. Here's the building we've already seen a piece of. Remember, we're not counting above the concrete podium. So if you start counting above that, 1, 2, 3, 4, 5 of the wood frame construction, 6 in the front from a fire department perspective, because the reach of our ladders, our ability to deploy to the upper floors, much less the void space, it's still a 6-story building. Now I ask you, Count them in the rear. 2 till we get to the top of the podium. 3, 4, 5, 6, 7, and the loft. Why isn't that a high-rise? No rear access, parking garage wrapped around these large buildings, courtyards. I will tell you, based on my experience, that a wind-driven automobile fire in the parking garage on the right would easily extend to the unprotected space in this building where we have over 250 dwelling units. The building at the bottom of the red arrow is a building fire that occurred in Rockville, Maryland on April 1st, 2014 when I was still chief. Now, the footprint of that building is 26,000 square foot. It's got the 3 wings, the center wing, the left and right wing. I also draw your attention to the adjacent building that looks like a pentagon, where at least on one front, that's 250 foot of frontage. Here's a close-up of it, 26,000 square foot per floor, 147 dwelling units. Look at the access. The roadway at the bottom of the photograph, the bottom left, is the exit ramp from Interstate 270 onto Shady Grove Road. I will tell you about that in a minute. Same complex. So we look at new type 5. We look at a traditional garden apartment complex from a Google Earth view. And I ask you, compare the risks. They're not the same. The morning of this particular fire, the genie was out of the bottle. You see what the top of the building looked like when it was being reconstructed. This is actually the exposure building in the top left. You see this loft business, these large areas of unprotected space on the roof, and all of the mechanical systems of the building, HVAC units, that's where plumbers will be sweating those lines, electric, all those things are in an unprotected portion of the building. This ladder truck is fully extended. We had to close down the interstate in order to get it into position to put the final bit of this fire out on the morning of April 1st. And you can see how far away this ladder truck remained from the building. Now, the practical reach of a best stream with adequate water supply out of that nozzle is about 100 feet. Actually, it's a little bit less. If the wind's not interfering, it can be a little bit more, but we say for practical purposes, 100 feet reach. We barely made it even position on the ramp from 270. Now, count these floors in the back. Podium, 1, 2, 3, 4, 5. You can see the challenge. This is what the fire looked like in that building when we arrived at a little after 4 in the morning. The building was due to be occupied in 2 weeks. You can see that lights are on in the second floor. So the first arriving units believed that it was in fact partially occupied. So this is the first arriving unit taking a dash cam photo from the windshield. First ladder truck arrives in the right frame. They set up very quickly and try to defend their position from there. You can see that this fire has now consumed a portion of the top floor in addition to the unprotected areas and is rapidly spreading both left and right. So the ladder is coming out of the cradle. We have water supply there. I'm going to ask you to pay attention to the direction of the flag in the right side of that frame. And then minutes later, look at the flag now. I would also point out that we were lucky because 24 hours prior, March 31st, 2014, there was a 40-mile-an-hour wind in a direction that would have spread this to the closest exposure almost certainly. That did not occur this morning. We believe that this fire was so large at this point that it was creating its own weather event. Heavy water is our only answer to that. We won't get into the particulars of that. Each one of these elevated streams flying from a ladder truck flows typically 1,000 gallons per minute. We were able to assemble 5 and bring that to bear. More importantly and happily, in Montgomery County, we had the underground water supply to sustain that for multiple hours. I will tell you, here in Hagerstown, that is simply not possible. At the peak of this, if you count the ground-mounted streams, the elevated streams that we were able to bring to bear, we were flowing approximately 10,000 gallons per minute. I don't know of too many municipal water systems that can handle that demand. We did get a hold on it. We were able to stop it in its tracks. I will tell you that's not been the experience everywhere in the country. This is kind of the after effect, and this is the threatened exposure in the bottom left, also under construction. Had the wind significantly drifted or changed, I believe we would have lost both buildings. There's that stream reaching the final area of extinguishment. Very difficult to get water supply established out there. As a reminder, I will tell you that that was an interstate highway. There are not fire hydrants on interstate highways. And more importantly, if you look at the overhead power lines in the bottom right, we had to take down power to be able to utilize this ladder truck. Very, very high voltage wires, and wait on the local power authorities to accomplish that for us. The end result, this particular fire remains Montgomery County's largest dollar loss fire in the history of the Montgomery County Fire Department. $22 million in climbing due to litigations. Now, what ended up happening here, we poured so much water on this thing that the structural engineers, I believe, refused to certify it. They tore it the whole way down to the podium and started over. I would ask you to consider this from our view. How many communities have the underground water supply to deliver 10,000 gallons a minute for 3 to 4 hours? How many fire departments can assemble 5 or more elevated master streams in a timely fashion? Here's an important point for all of you. The city of Rockville had recorded and documented over 400 building inspections for this building prior to the fire. One of the concerns with the legislation that was originally proposed, as I understand it, is that much of that work would have been relegated to the State Fire Marshal's office in Maryland, and they are simply not resourced to get anywhere close to that. I'm not aware of any fire prevention bureau, even in the largest metropolitan fire departments, that could do half of that work. At our peak in Montgomery County, we had 45 employees in our Fire Prevention Bureau to cover 500 square miles. These things are going up everywhere. And I don't think that legislation that would push that work to any municipal agency without the resources to come with it is a realistic expectation. Personal opinion only. What happens when this construction arrives in under-resourced suburban and rural areas? I'm being selfish here. I'm thinking about where I'm working today. We are not resourced, period, end of story, to deal with those kind of fires. And a question of mine that I really don't understand, and I don't know if they're on this call, why isn't the insurance industry pushing back? The experience nationwide is pretty hateful. I won't bore you with these. I will tell you that every one of these jurisdictions has had at least one of these experiences. They're all over YouTube. You can search any one of them and you will see links to multiple versions of this, some wind-driven, some not, and the experience is largely the same: burn to destruction or collapse. We've had our share of experiences. This dates back a couple decades ago when our first introduction to this kind of construction. This was a torch, either plumbing or welders, I don't recall, that ignited a fire on the top floor. The fire department was less than 2 minutes away, and this is the result. Conshohocken, Pennsylvania, some of you may be familiar with this. This is what it looked like when the fire department first got a photograph. Less than 10 minutes later, this is no less, and once again a cynical expression, but solidified gasoline. And the smoke plume, I think, bears that out. What if the wind would have been blowing in the right direction that day? Look at the stuff that's already completed behind it. This would have been a true conflagration. Now, make that an occupied building in the middle of the night in a small town like Conshohocken, Pennsylvania, that is only resourced 2 fire stations, I believe, and a volunteer crew staffing. I think the public assumes that our codes are adequate. You know, large loss fires, greater than $1 million in loss, account for less than 1% of our building fires. In 2014, I believe the buildings under construction in their entirety reflected $2.8 billion in losses. Code enforcement and compliance can no longer be entrusted to the fire department. I think it has to be pushed to the developer and contractor, and we can talk about that from my perspective. During the Great Recession, beginning in 2008, 70,000 jobs were lost in the fire department nationwide. What about fire departments where prevention bureaus don't even exist? Can we entrust this to the contractors to do the right thing? I don't know the answer to that. We have to do a traditional risk assessment, I think, and determine the practical reach of an elevated stream from wherever they can set up. I've already shared with you that that's about 100 feet. I will tell you, based on real experience, needed fire flow, the traditional measure of that in design world and water delivery world, and what fire departments are actually able to deliver on target, they're not even close. From our perspective, it's simply GPMs versus BTUs of energy. Always has been, always will be, regardless of the construction methods. So, as we start to wind, I think we have to, as a group, get to the point and really decide what do we want sprinklers to accomplish. If we're going to say they're for life safety only and we write off the building, then let's declare that up front. Designs traditionally for 13D systems are based on a 2-head flow. For a 13R system like we're talking about here, 4 heads, and for the actual hazard, a full 13 system. I would submit that in just about every example you look at where fires have occurred in these buildings, it is well beyond a 4-head design of a 13R system. And that points us back to a full 13 system. We have to evaluate these minimums and maximums change based upon the assumption that in a 13R system we're going to put the fire out every time. The sprinkler code exempts combustible attics and service areas. I think developers and people have taken advantage of that at the future expense of people that occupy these buildings. And if you connect our current knowledge of fire growth with all the other risk factors we've talked about in this conference, then I think it would give you pause and at least raise your eyebrows. I certainly hope it would. Not here to lecture about sprinkler code comparison, but we know that the difference in density, GPM per square foot, between a 13R and a 13 system is half. Half. There is no host stream allowance for a 13R system for the fire department. The rest of it remains largely the same, but those two things cannot be ignored. We have to bring our stuff with us and apply it on target in a 13R system, period. I would ask that in any performance-based design, as we lean forward here, that we collectively reevaluate the height and area requirements of these buildings. Provide realistic fire department access during all phases of construction. Provide a greater focus on water supply if we're not going to do the first two. Deal with the unprotected areas. Determine a realistic evacuation time. If we go left of boom, a lightning strike that ignites the unprotected attic, and somebody becomes aware of the fire. Actually, the one I showed you in Rockville was a state police officer driving up 270 who pulled off the apron and started the whole thing in process. So that fire had a good head start. This is not just a problem during construction. You know, this is a long-held belief of mine. Please don't take any offense to it. The developer and the builder get to walk away from this problem when they complete construction. If you're a fire chief in a community like we see here, you own the problem for your whole career, and actually through several fire chiefs, because what is the expected life cycle of that building? Whatever strategies we come up with, I think should reasonably survive the expected life of that building before someone knocks it down. You know, the pure title of the 13R standard is for low-rise residential occupancies. Really? Plain language and common sense are out the window here. Those of you that know Frank Brannigan, a legend in the fire service and building construction, you know, I appeal to my colleagues, what would Frank Brannigan say? I know what he would say. He taught me. He wouldn't stand for this for 2 seconds. Unit density, you know, in a traditional garden apartment we have 16 dwelling units. Now we're looking at 150 or more. What is the ability of occupants to escape that building, or in a really pressing situation where the sprinkler system doesn't work for whatever reason, or the fire is outside of the bottle, how can the fire department deploy to make an effective impact there? Particularly when they can't get to it with their vehicles. Exterior fire spread has always been a concern. It's more of a concern with flammable exterior construction. We've talked about height and area limitations. We've talked about the limitations of 13R sprinklers, and we've talked about the limitations of traditional municipal water supplies, which in many, many communities throughout the nation are designed to take showers and flush toilets between the hours of 4 in the afternoon and 10 at night. This is an interesting analysis from a true fire protection professional after a fire at Six Flags Haunted Castle that killed 8 teenagers in 1984. I take you back to the very first slide I showed you. There is no bigger supporter for automatic sprinkler protection on planet Earth than me. However, this is an example where sprinklers were sometimes thought of as a magic bullet that could solve any fire protection problem. That's simply not the case here. Just simply isn't. So, what can we do? We can maintain site accessibility and water supply from the minute it comes out of the ground for the fire department. That includes paved roadways, at least crushed stone roadways where we can get in and set up these elevated streams. We have to insist on no smoking inside secured areas. I think the developers and contractors should be, as part of law, required to appoint fire wardens in any place hot work is going on. We have seen these end badly over and over and over again. I think we have to mandate training for all construction workers about just how serious an issue this is, and then the fire departments or the code officials, pardon me, will have to reassess traditional acceptance practices when we're dealing with this unusual hazard. What I would like Steve Lohr, the tougher stuff, structurally independent stairwells. If we're not going to fix everything else we've talked about so far, then give me an area of refuge where firefighters are safe and the public is safe, and we can cohabitate while they're trying to get into or out of the buildings. And if, for whatever reason, the buildings fall down around them, which they traditionally do, they're not going to lose their lives. I think this first floor pedestal exception is ridiculous. And I understand that's selfish. The reason I think it's ridiculous is from the fire department perspective, it's how far above the ground is the only thing that matters. And we can't deploy adequately for these larger fires to those unprotected spaces with this exception in place. I think that the full use of 13, which would cover the unprotected spaces, is an option. Is it worth the bang for the buck? Not sure. I believe that there's probably people on this call that are infinitely more qualified than I'll ever be to make that determination. I also think it's very practical. I have been to a dozen major fires in my career where an exterior fire outside of the protected space from a discarded cigarette, spontaneous ignition of mulch, started on the outside and run right to the attic and spread horizontally in all directions. We could at least insist on a one-story grade level buffer of non-combustible construction. And then go back and reevaluate all these other features we've talked about. If I could have 5 things I'd want to do right now, it would be these 5. Change how building heights are measured. We already talked about that. Horizontal separation falls in there as well. Interpret the scope of 13R in Type 5R2. 70 feet is 70 feet. Without a fire pump, et cetera, I'm not sure these things are going to measure up on game day. We should focus on flow, not PSI. A full 13 system fixes this problem. Structurally independent stairwells, exterior wall covering, and all the things we've talked about before. This slide is interesting and it's a little bit dated. This was prepared in the middle of calendar year 2014, so I acknowledge it may be a little bit out of sync. This came from 2 separate consulting engineers who work every day in the business of designing sprinkler systems. I won't name them. They provided me this information. Sprinklers typically represent 2% of the cost of a new construction project overall. The delta between a full 13 system and a 13R, 0.75%. Why isn't the insurance industry jumping all over this? These are the examples they provided me per square foot. I assume they're accurate. I have always maintained the position of bullet number 5 that we should build everything in this country under the assumption that there will be 1 or more fires somewhere in that building during the building's expected life cycle. And then the larger question of what happens when the sprinklers don't work. We all know, or you should know, that in Europe, in New York City, and some other places, I actually serve on a committee that's working this phase 2 of this issue here, the fire safety challenges of tall wood buildings. The difference is that these will be large mass structural elements of laminated wood, etc., protected and unprotected by gypsum and all those other things, but that's out there. 30-story high-rises made out of wood. I think that all the special interests just need to come together and have an adult conversation here. Bureaucracy is what it is. The code process is what it is. But if we can get everybody talking about this problem based on our experience since the codes have been created, I think we can have more favorable outcomes. I want to make sure we're not headed here. And it's my personal opinion only that we're close. That concludes my presentation, ladies and gentlemen. I'm happy to entertain questions, discussion,